Okay, this is a very short demonstration of something we've seen in both classes today when we looked at the problem involving conjunctions and we looked at negations, and it looked like two things were the same. It turned out they weren't, and let's look at a truth table proof that they're not. So we've started with two truth tables here for P and Q, and what we're going to do now in the first one is we're going to look at the conjunction, P and Q. Okay, and we should know now that the only way that can be made true is when they're both true. Otherwise, it is false. Conjunction is easy to make false. When either one or both is false, then the conjunction's false. Now, if I write the negation of that, that's this. That's the not P and Q. So that takes the opposite truth value in each case. So it's easy to make true and hard to make false, only false when they're both true over here. Okay, so this is the negation of the conjunction. Now down here what I want to do is I want to look at each of their negations. I'm going to negate P first, so we flip all the values from T to F. And then I'm going to negate Q and do the same thing. I flip all the values that are T to F, all the ones that are F to T. So this one's an F, this is a T. Okay, and now let's look at the conjunction of these two. That's not P and not Q. Now, the idea of this truth table side-by-side comparison is a lot of people, a lot of students have said these are the same, but it turns out they're not, because watch, we're looking at these two columns and the conjunction of them. No, they're easy to make false. If either of them false, this is the only one that's true on the bottom. Otherwise, it is false. So these two, if you compare them side by side, are not the same, which means these two are not the same. There's a difference between negating the conjunction and taking the conjunction of the negations. These two are not the same. So that's all this was supposed to show. I hope it was helpful.